We're going to go through a couple of examples that use friction in the problem. So this example is a puck of mass 0.30 kilograms is sliding across or along an essentially frictionless patch of ice at 6.0 meters per second. It hits a rough patch with a coefficient of kinetic friction of 0.10. How long will it take for the puck to stop, and how far would it travel? So I've started to set up our question here. I've got a free body diagram showing that the frictional force is in the opposite direction of motion. We're going to use motion as positive, the positive direction. So F net here is equal to the force of friction, and that's because we've got Fn and Fg as opposite and equal, so they're not actually going to be included here. And I'm going to figure out the F net first. So we also know F net is mass times acceleration, and frictional force is mu k Fn. And that means that we've got mu k mass times gravity, right? Because Fn, the magnitude of Fn is the same as the magnitude of Fg, and Fg is mass times gravity. And look at this, I've got mass on both sides, so I'm just going to actually divide that out. So acceleration is mu k times g. And I'm going to start off by looking for time. I can also add to the given and requires that v2 equals 0, because we know it's coming to a stop. So I first need the equation without d in it. So that will be v2 equals v1 plus at, and I'm solving for t. So at equals v2 minus v1. And then time is v2 minus v1 over acceleration. And let's keep in mind up here actually as well that ff is in the negative direction, so that means so is acceleration. So acceleration really is the negative of this value here. So acceleration is going to be this negative. So time is v2 minus v1 over negative mu k times acceleration due to gravity. I just realized I didn't actually put acceleration due to gravity in here. And that means now I can solve for t by substituting in for time. So we've got v2 is 0 minus 6.0 meters per second over negative 0.10 times 9.8 meters per second squared. So I will in fact be left with seconds. So we've got negative 6 divided by negative 0.9. So I'm going to pull out my calculator. And we see we get 6 divided by 0.98 is positive 6.1. So I can write my statement. Therefore, the puck stops in 6.1 seconds. And then we still need to find the So now we're using an equation that does not have t in it. So we're going to use v2 squared equals v1 squared plus 2ad. And we're solving for d, so I have to rearrange this a little bit. 2ad equals v2 squared minus v1 squared. So d is v2 squared minus v1 squared over 2a. And v2 squared minus v1 squared over negative 2 mu k g. Plug in our numbers. 0 squared minus 6 meters per second all squared over negative 2. 0.10 times 9.8 meters per second squared. So we are going to be left with meters. So we've got meters squared per second squared on the top and meters per second squared on the bottom. So our units work out nicely. So I've got negative 36 meters squared per second squared over, and what's 2 times 0.98. So the bottom here is negative 1.96. So you see we've got positive on the bottom and the top again, which means we're going to end up with a positive number, which makes sense since it's traveling in the positive direction. Oop. Yep. So 36 divided by 1.96 is 18 meters. Therefore, the puck travels for 18 meters.